Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's Design News webinar, Aerospace Quality Meets Precision Motion, Servo Gear Train Solutions for Demanding Environments. It's sponsored by Harmonic Drive and broadcast by Informa. I'm Peter Krass, and I'll be your moderator today. Before we begin, I have a few very quick announcements. This webinar is designed to be interactive. On the right-hand side of your screen, you'll find a navigation center. You can see that on the screen now. And that's where you can learn about today's speaker, download resources, and participate in the Q&A session we'll have toward the end of the webinar. If you have any technical difficulties during this webinar, first thing to try is refreshing your browser. That will refresh the whole webinar console. If that doesn't work, however, just type your question into the Q&A area, and we'll be glad to offer one-on-one assistance. And finally, before you leave us today, we ask that you complete our survey. Your feedback will provide us with valuable information on how we can improve these events in the future. So I hope you'll fill that out before you leave us. Thanks. With all those announcements done, let's move on to our presentation, Aerospace Quality Meets Precision Motion. To discuss today's topic, we're joined by Henry Kim. Henry is a regional sales engineer at Harmonic Drive. If you'd like to learn more about Henry, please visit the info tab that's in your navigation center that I just mentioned. With that, I'm going to hand it over to Henry Kim. Henry, take it away.
Thanks, Peter. Hello, everyone. Appreciate everybody's time and coming to our webinar. I'll try to make it as simple and informative as possible. Most of our customers and aerospace engineers know us as Harmonic Drive, and I'll try to do my best to try to give you some insights. So we'll start out with just a brief introduction on strain wave gears, then move on to design challenges in operating in extreme environments, and some key takeaways and some practical guidance, because as many of you engineers know, time is one of the key elements that becomes important decision-making process. So just a quick review. A lot of people call our type of gearing as harmonic drive gearing, but is mostly known as strain wave gear. And the reason why a lot of our aerospace engineers use our product is because of its high torque to volume weight. In terms of the torque package or the torque density per package size, we are the primary selection. Of course, you can use heavy gears in aerospace, but you don't want heavy gears in aerospace. You want things that are going to be very compact, very lightweight, and a very high torque density. And we're known for zero backlash. That's why our gears or strain wave gears are used in all of the, majority of the, I won't say majority, I want to say 95% of the robot arms in the world. Whether it's a robot made in Japan, robot made in Germany, or robots made here in the US, they use our harmonic drive strain wave gears. And then I'm just going to briefly go over the three major components of what a strain wave gear looks like. This is just a quick overview. I don't want to spend too much time, but there are three main components: the circular spline, the flex spline, and the wave generator. So the wave generator assembly is nothing more than a elliptical bearing, and it's a very thin raced elliptical bearing. And its standard material is 52-100 steel, and it is designed to actually generate the wave of the strain wave gear. The next component is what we call a flex spline, and it is the material actually flexes. It's a steel alloy, and it's very thin wall. And we basically place the wave generator bearing inside to actually generate that elliptical wave. And the teeth obviously is on the outer diameter. And the flex spline conforms to the elliptical shape of the wave generator bearing. And then the last parts of the third part of the strain wave gearing is the circular spline, which I'm holding in my hands. And this is the rigid circular ring on the, as the third component of a strain wave gear. It has teeth cut on the ID of the ring. I probably can't see it too well on the video, but it has two more teeth than the flex spline. And you can see that the tooth engagement is on the opposite end of the two regions. And one of the reasons why we get zero backlash is that we have a very high engagement of gears. Up to 30% of our gears are engaged at all times. So what I'm going to do is, instead of talking too much, I would like to kind of show you a quick video. Some of you may have seen it before, but it kind of outlines the principles. Let's just cue up the video right now.
High-precision, zero-backlash harmonic drive gear component sets are key to the performance of our gearheads and servo actuators. Harmonic drive component sets consist of only 3 precision components: wave generator, flex spline, and circular spline. The wave generator is the driven or input element of the transmission. A hub having an elliptical shape is fitted within a special thin raced ball bearing to create the wave generator. The flex spline is a robust, torsionally stiff, yet radially compliant component with external gear teeth, capable of reliably transmitting high torque loads. The circular spline is a rigid ring with internal gear teeth. The circular spline has 2 more teeth than the flex spline. When inserting the wave generator into the flex spline conforms to the elliptical shape of the wave generator. Rotating the wave generator creates an advancing waveform on the flex spline. When assembled with the circular spline, tooth engagement occurs at each end of the major axis of the ellipse, and up to 30% of the total number of gear teeth are simultaneously engaged. The rotation of the wave generator causes the flex spline and circular spline tooth mesh to move around the circumference. Since the flex spline has 2 less teeth than the circular spline, rotation of the wave generator leads to a relative movement between the flex spline and the circular spline. Harmonic drive component sets, gearheads, and servo actuators are used wherever zero backlash, extreme precision, and high reliability motion control is required. Harmonic drive, advancing the technology of motion control through innovation.
Okay, so the term harmonic drive is something that's well known here in the US, but I want to give credit to the inventor, Mr. Walt Musser. The strain wave gear was actually invented here in the US. Just so that everybody knows, harmonic drive was formed in the late 1950s, and the actual strain wave gear technology was patented here in the US. And some of the applications that Mr. Musser has been successful are an aircraft ejection seat, other aerospace release mechanisms, and power steering. So it's been used in multiple applications, but I just want everybody to know that this was invented here in the US. We just want to make sure that he gets credited for it, because the term harmonic drive is also a patented, but also licensed. So nobody can use the term harmonic drive on without our authorization. the name harmonic drive is something that belongs here in the US. Okay, so I'm going to kind of go through a short, or try to keep it a short, applications on some of where the original usages were. The first application was for a satellite in 1962, but it was also used on the original rover that was driven by, I guess, Mr. Buzz Aldrin. This is a photo of him signing the original moonwalk that he did at our headquarters in Beverly, Massachusetts. So the photograph is located in our headquarters, but obviously Mr. Buzz Aldrin is an icon in the space industry. So we're very proud of the fact that we were part of the original space program when it first started. Moving on to some of the more recent ones that we've been successful are some of our rovers that are in Mars. We have the latest one is not shown on here, but the some of the past ones are your Mars Spirit and Opportunity. This was launched back in 2003 and was originally designed for only a short period of time, but it lasted for many number of years. What's on there is what our gears are, strain wave gears are on the wheel drive, the steering mechanism, the actual robot arms, and also the pan-cast master assembly and the high gain antenna. I think that's more of a gimbal to point the antenna. So these were originally designed for obviously battery operations, as you can see from the solar panel, but they've been pleasantly surprising, as Opportunity's last communication was, I think that's a typo, but in June of 2020, let's just say 2010. So anyway, the idea behind it is these Mars rovers are using harmonic drive strain wave gears because they were lightweight, and there's a big price to pay when you move something this large scale onto a spacecraft to be able to launch it into not just a space, but all the way to Mars. So you can imagine the mass and the weight and the torque density that's required to be able to support the Mars rover program. So I think the latest one is in Mars is called Perseverance. We have a rover out there, and that's also using our strain wave gears on the arms. I just wanted to show this as a the fact that we have gears that's been out in space for an extended period of time, and the most recent one, I believe, has the sample soil in canisters waiting for the next return trip. So JPL is waiting for the funding for the next launch to Mars to pick up those soil samples that are in the canisters. So some of the other more common applications I wanted to kind of share with everybody is that there are a lot of satellites, GEOs, MEOs, and LEOs, and there's a much higher volume of LEOs orbiting the Earth. LEO stands for low Earth orbit. Typically in the lower altitude, between 500 to 1,200 kilometers. And majority of those satellites require some sort of a solar array drive to deploy the solar panel. And our gears are being used because they're lightweight and they need the torque. There's usually a motor or an actuator opening up those solar array drives and then adjusting for the proper angles for getting the maximum amount of sun so that the power can be replenished over a period of time. But we do have some larger satellites that are doing the GEOs for that are actually orbiting at the same rate as the Earth. So anyway, these are some used in both telecom and weather tracking. So I just want you to be aware that many of our satellites that are orbiting that you may see in the sky at nighttime are mostly the LEOs that you can see, but those are using our gears for deployment of the solar array. Before going too much deeper, I know that a lot of people have asked, hey, do you guys have actuators? Can you use actuators? And what I wanted to share with everybody is that we do not have actuators in space. Most of our gears are what we call component sets. As you saw in the video, you have the flex spline, circular spline, and wave generator bearing. Those are the components that are in space. But we do offer some units for ground testing that are known as gear units. These are some gear units. I'm holding one in my hand. It's a housed unit. It's about 21 millimeters square gear unit. And it's got an input bore and an output shaft, but this has a small torque range of about 1.4 Newton meters. It's about 21 millimeters square in size. So some of these are used on gimbals and some of them are used for small lightweight testing, as well as some of the larger units that we can also supply. But those are primarily, actually we do have a handful of customers that are using a little bit larger size. They're like 36, 38 millimeter housed units, but they're special material housed units for satellite applications. But I just wanted to share with you that harmonic drive comes in 3 different packages. Do you want it with a brushless motor and a servo actuator, which for ground testing is fine, they're not actually meant for space, or gear units, something that has an integrated bearing and a housing, so you can, put a step motor or servo motor that you can mount quickly to do a little bench testing. Or if you want to do a complete custom solution, then you can do your own housing, custom bearing, whether you need a ball bearing or a cross roller bearing. You can do your own type of housing and structures. So majority of our space customers are implementing the cup set, the component gears. But I just want you to know that for prototyping or any type of quick engineering requirements, we can offer other package solutions. So some of the key points to consider is for aerospace, using our harmonic drive gears, it's always about size, right? How much torque can I get out of a package size? So whether you use, by the way, our gearing starts at 30-1, goes all the way up to 161 as a standard. 30-1, 50-1, 80-1, 100-1, 120-1, and 160-1. But it's always how much space do I have to put or to get the torque density that I need to accomplish using the motor size and the gear size. So that's one of the big questions is what kind of a envelope size do you have available? And then do you need a hollow bore? Like in this instance, we have a through hole of a certain size, whether you need to route cables or you have other things that need to route through the center of the shaft, because the output is mounted onto the the output shaft is mounted onto the base of the flex spline as a typical output. And then what kind of a torque are you expecting to produce, whether it's average or peak torque, and what is the true operational and storage temperature? Those are some of the key factors that you need to determine for the package size. We typically ask that the engineers design towards the repeated peak torque value that is published in our catalog, but certain customers have certain requirements where they try to push that envelope, and we need to know things like duty cycle, and then important thing is this is going to be in space, so you need to know what kind of expected life you're running. A lot of the LEOs have fuel that can stay up in orbit for 3 to 5 years, but you also have to determine the number of cycles you're expecting on the output side. And then obviously you have to look at, hey, what kind of a vacuum rating, is there any type of specific pressure or humidity, or what type of environmental considerations you have to keep in mind for your applications. So just to kind of sum it up, you really need to know what is the operational environment. Yes, a lot of people just say, hey, this is going to be non-operational until it gets deployed, but you really need to know what is the operational environment in terms of temperature. Some of that will determine the type of lubrication that you use. And then what is the expected lifetime in terms of number of cycles or the number of years in service. And some of the other major concerns you have to think about is, can you use our standard material, steel alloy, or does it have to be stainless steel, whether it's a 17.4 or 15.5 material? Because the bearing materials are typically 52-100 steel. So in order to get stainless, requires some additional time in manufacturing. So you need to determine what type of material is required for your application. And then obviously you're going to require some sort of a outgassing or minimizing the outgassing of the materials, whether it's a CO material or whether it's material on the wave generator bearing itself. We do have a standard nylon material on the wave generator bearing itself. So we're going to have to determine the proper lubrication for your application. And typically the customer decides that, but we have some discussions about what type of outgassing requirements that you need. And this becomes critical. The outgassing becomes critical if you have optics on the satellite, if you have a pointing mechanism, or if you have other sensitive equipment that you cannot have any contaminations from either the lubrication itself or the material itself of the wave generator bearing. And then lastly, I didn't want to not include is the timeline, because as in anything, people need to do qualification and testing as quickly as possible. So when we typically engage a project, we kind of look to see when do you have to have the engineering model, and when do you need the qual model, and when do you need the flight models, because there are a lot of aerospace flow downs that come down with flight models, and we need to know what they are. These aerospace flow downs, it's like 20 pages that you have to look through to see, hey, what are all the requirements for this particular application? That's things like material certs, if there's any special modification that need to be done. So lead time is always something that engineers ask and say, hey, I want to do this and this and this. Can you guys do it in a reasonable amount of time? So the issue comes down to, hey, what type of certifications do you need? What type of materials do you need? And what type of testing do you need in terms of the final product? So a lot of those questions have to be addressed early, instead of waiting till the very end and say, oh, by the way, we need to get this and this done before you have these aerospace flow downs come at the last minute. It goes, no. We need to know what those are from the beginning. So that determines the time schedule for a lot of the requirements for aerospace. Okay, I talked too much on that slide. So once again, some of the key design points for a lot of these, and these can be non-space, but even any type of applications where you have an aircraft, that's going to be, flying in certain altitude, you always have to determine with our strain wave gears what type of grease selection has to be made, and is the temperature swing for the actuator that you're designing, is it going to be always at a low temperature, or is it going to swing from high to a low temperature? Because one type of grease is not the best for low temperature. It may not be the best for high temperature. So you need to select the right type of lubrication to make sure that the gears perform and to your expectation and the life. So we always encourage that the customer give us as much details in terms of the environment that our gears will be functioning, and then we work with the customer to select the proper lubrication. The other thing that you have to really look at in terms of design for our strain wave gears is the wave generator bearing. We call it the ball retainer. I'm going to try to see if I can point to it. See, there are balls in the wave generator bearing, and there is a separator that separates the ball from each ball. And the standard material is a nylon material, and that can outgas. I believe it's nylon 66. And so in certain applications, customers cannot use that nylon ball separator. So we have used PEEK. It's a material that's lower outgassing, phenolic, or bronze. We've also used other materials that are not listed here because customers specified them. If we can make it, we'll basically try to do our best to accommodate the customer, but the PEEK and phenolic are the most commonly used for space applications. So lubrication becomes critical, and ball retainer material becomes critical because of those three components. We want to make sure that the actuator that you're building and designing will not have any outgassing issues. So these two are probably the more critical ones that we decide. Obviously, you'll ask for modifications on the flex line, whether you want additional holes, you want dowel pins, those things that we can, work with you. But once again, we always want to have as much engineering information up front so that at least we don't have any, continual changes. We want to get as much of the key points and key designs that you have in mind so that you don't have to make too many iterations on the development side. So this is actually an application note that's on our website. Our website has a lot of helpful information. I know it's a bit a lot, but under videos and technical information section, we have some good information. And one of those was an aerospace applications, and it specifically talked about a solar array drive. This is a side view where one of our customers actually picked a specific size and ratio. And basically, in this particular application, they ended up using a stainless steel material, and they used a hollow shaft, meaning they wanted a larger through hole to the center of the flex line so they can run cables through. But I just want you to be aware that we have application notes for a lot of our component gears on our website. We have a lot of good training material also on our website. So the key takeaways, which I want to kind of stress a little bit more, because of the fact that we want to reduce the number of iterations and we want to do things right the first time. That's kind of my personal motto, try to do it right the first time. In the early design stage, we'd like to see if we can just take a standard COTS material, standard gears in our catalogs for doing quick engineering and development models. So in the early stages, we'd like to see if there's a way you guys can, way engineers can reduce all the aerospace flow downs that's not required for flight models, so that you don't have to have, hey, material search for standard product or process search for standard products, because it will make it much easier for you to get parts quickly, so that you're not trying to ask all of us to meet all the aerospace flow downs for a simple prototype development. So, and typically we ask that the customer say, or customer accept, if we can just apply a certificate of conformance rather than have to do all the FAIR requirements and other material certs or process certs, you can get your parts much quicker. So that's something that I want to stress is, hey, for initial development of a custom actuator for aerospace environments, please start out with the cost solution, and also keeps the cost down. You know, some people say we're using the Moneyball approach here. We're not using, you know, we're not using expensive parts just to do prototype development. So, and even still, some of those Mars rovers are using COTS gears. Yes, we probably put some extra holes in certain places and a dowel pin in a couple of places, but most of our aerospace applications are using COTS gears. But we also have customers that want all stainless. And one of the concerns about stainless is the wave generator bearing. The bearing to get stainless, there's a long lead time for stainless steel bearings because they're not always produced in high volume. So if you can use a hybrid solution where you could use a standard material for the circular spline and the flex spline, and then maybe use a hybrid version, is using the 400 series 440C stainless steel bearings for the wave generator bearing. So, or the other way around, use 15.5 or 17.4 material for the flex spline and the circular spline, and just use the standard bearing, 52-100 bearing. We call that kind of the hybrid gear set, so that you don't have to wait for a very long period of time to get the stainless steel bearing. Again, stainless steel bearings are not made in high volume, so it's something that you need to consider. Do you really need a stainless steel bearing for your application? Now, we have used stainless steel bearings for some deep space applications because that was what was needed. But I think a lot of our customers can get away with just using a standard 52-100 bearing with stainless steel gears. And then the last thing that I would also recommend is conduct some sort of a dry test for your actuator, using either a cryo or cryovac chamber, either at your facility or at another test facility, so that you have some validation of the torque performance at low temperature by monitoring some of the motor currents. So this is something that we always ask our customers to do is, and obviously before customers sent out the Mars rovers, they did some very extensive testing at JPL. So we also ask that our customers who do send stuff out to space, please make sure to do some actual cryovac chamber testing to get and validate your own test results, and not just rely upon catalog data to say, okay, I got this much torque for this size and ratio. So conducting load testing is something that we very strongly recommend before you send anything out of space or anything on an aircraft. So I think I just want to give you some general guidelines. aerospace has a huge amount of requirements, um, and aerospace quality flow downs. It's just we may be able to get by with a lot of standard components to do a lot of the testing, but I can understand that some customers really require stainless steel material, and we'll accommodate them. But as a general rule, we have a lot of things out in space that are just standard materials. So I just want our aerospace engineers to be aware of that. Hey, you don't really need stainless unless you think your application really demands it or requires it. Okay, I think I've talked too much, Peter.
All right, thanks, Henry. That was really good. Thank you. Let's move on to our Q&A. Audience members, if you have a question for Henry, this is your time. Just go to the Q&A icon that's in your navigation center, type your question into the text box and send, and we'll do our best to get to all these questions. Any we don't get to, we can share with Henry and he can reply to you offline. We'll do our best to get to these. All right, let's go to our first question. Oh, okay. Is there an easier way that we can get grease? That's the question.
Is there an easier way to get grease? We do.
Yeah.
We can supply grease, but some of our customers find their own sources for grease. Whether it's Castrol, whether it's Nye, they use their own brand of grease. But we can work with them.
Okay, good. Let's go on to our next question. Do you offer servo motors and actuators that are space rated?
We do not. To be honest, most of our applications are using just the component sets and a handful of house gears, but they're special material. So answer is no motors and no actuators. As of today, we're only supplying component sets and some house gears.
Okay, good. Thank you. Next question. This is a question, I guess, about harmonic drive. Do you offer engineering and technical services, like in addition to these interesting products?
Yes, we do. I'm a degreed engineer as well, but we have a full staff of engineers. And usually we end up signing an NDA to make sure, or it's a mutual NDA that we sign so that both parties agree to share some of the application details. And we also have to work closely with the engineers. So we usually ask for a mutual NDA, but we'll work with the customer on what his requirements are.
Okay, good. All right, next question. When you're manufacturing your gears, what quality systems do you use? Quality system.
We're certified for ISO 9001 and AS 9100, and I believe that certificate is actually on our website. If you ever need a copy, we can download it to you and send it to you as well.
Okay. Next question. You talked about the gear ratios. The question is, do you offer strain wave gear ratios higher than 160 to 1?
Yes, we've done some special gear ratios that are over 200 to 1. But as a standard offering, catalog offering, we stop at 160 to 1. But once again, we have done over 200 to 1 ratios. But as always, we want to kind of know, can you go up a larger size? If you can't, then we need to know what your really torque requirements are. So the answer is yes, we can go up to 200 to 1 or higher.
Are those sort of custom projects?
Yes.
Yeah.
You can imagine how small the gears. So just on that general question, it's the same form factor, whether it's a 30 to 1, 50 to 1, 100 to 1, 160 to 1. The 200 one might go a little bit deeper, and the gear teeth get even smaller. So, yes.
Very precise. Okay, good. All right, thank you. And here's our next question. Approximately how many harmonic drive gears have been used in space applications?
I'm going to say thousands. I can't give you exactly the number, but we have a lot of our gears that are orbiting. And as you know, we have a few units on Mars. So I'm just going to say over 1,000. I'm not going to say more than that. So.
Okay, very good. It looks like we've answered all our questions, so that's really great. Henry, any closing statements before we sign off?
Please, if you have any application questions or applications, contact us at info@harmonicdrive.net. I am one of 10 engineers. I am a direct employee of Harmonic Drives, and we all want to make sure our customers' requirements are met. And, this is an engineer solution. It's an engineer part. So we want to make sure we engage the customer so that we can meet all their requirements. And we want our gears to last.
Very good. All right, thank you, Henry. We really appreciate your time and your expertise. I'd like to thank our sponsor, Harmonic Drive, as well as everyone out there in the audience. We appreciate your attention and participation. Within the next 24 hours, you'll receive a personalized follow-up email with details and a link to today's presentation on demand. You have colleagues and peers who couldn't join us today. Let them know they can check out this webinar on demand. And with that, on behalf of our guest, Henry Kim, I'm Peter Krass. Thanks for your time, and have a great rest of your day.
Have a great day, everyone.